Hello, everyone, and welcome to the third session of the Digital Tools for Green Building Design webinar, organized by Share Green Design, Kenya Green Building Society, and at CSTI. My name is Danielle, and I'll be hosting the event. Today, we're going to focus on the topic of sustainable materials. Fundamentally, materials play an important role in enhancing the overall performance of a building and in achieving the goal for sustainable construction. The selection of materials is an essential and critical phase of buildings design, making it possible to reduce their carbon emissions, save natural resources, and reduce waste, and even strengthen the local economy. To discuss this subject today, we have a great group of speakers from different backgrounds that dedicated their work and research to shift the paradigm towards a more sustainable future. We're going to have Phanos Hadjikyriakou from 2050 Materials, Rachael Mutheu and Githaiga from the Kenya Green Building Society, Aida Zare from Shiraz University of Arts, and as we had a last-minute change, Neil Turner represents on behalf of Ecological Building Systems instead of his colleague, Joe Fitzgerald. I would like to thank all of the speakers for being here today and also thank everyone watching us live on YouTube and remind you that you can write questions to our speakers on the YouTube live chat at any time during the presentations and they will be answered during our questions and answers session. Now I will give space to our first speaker, Phanos Hadjikyriakou. Welcome, Phanos.
Hi everyone. Thank you, Danielle. Really nice to be here. Let me try to share my screen quickly. Okay. Let me know when you can see my screen.
Yes, we can see it.
Okay, great. As I said, very nice to be here and talk about sustainable materials, especially because 2050 Materials, the company I work for, is a company that's focusing solely and primarily on sustainable materials. So what we do at 2050 Materials is that we are building a material library and a platform to enable sustainable and low carbon building design. Now, we come from a team that has backgrounds in ESG, construction, and software, and we currently have our initial platform out, so what we call our beta out, which is being used by around 700 users already. Now, a little bit of a background of why we chose to work on this specific topic, even though I'm sure it's already probably quite obvious to a lot of you here. So there was this quote by the UN a couple of years ago that said that groundbreaking innovation is needed in cities because that's where the battle for sustainable development will be won or lost. There's really good data to support that statement. So we need to build 2 billion new urban homes by 2050. And today we're emitting a staggering 3.9 gigatons of emissions simply due to the building materials that go into these new buildings. Now, if we want the world to stay below 2 degrees of warming, we need to reduce these emissions by at least 50%. So for our team, this is the number one sustainability challenge to work on. And it's especially an exciting one because, as I'll show in the following slides, there's a lot of innovation that's happening around construction materials. Now, the very specific problem we're looking at Carbon Delta is that currently the construction sector has no cost-efficient way to build these necessary sustainable buildings. While there are examples, and I'm sure that on the Share Your Green Design website, you can find a bunch of examples of sustainable buildings, it's unfortunately still far from being the common practice in the sector. And a big reason for that is that it just costs more money usually to do the necessary processes which define what a sustainable building is. So more specifically, you have these large architecture, engineering, and construction companies that are committing to deliver sustainable projects. Now, these companies, in our research, have no tools that allow them to translate these sort of targets into a design practice. So what that means is that usually there are external professionals that have to do with sustainability factors that come into play to do a lot of this translation. So if you're an architect that has worked on such a project, I'm sure you can vouch for the fact that it's quite a tiring process and also simply costs more money and takes more time. And then finally, and really most importantly from a climate perspective, the design process is unfortunately still decoupled from the actual materials procurement process. So what that means is, even with the best intentions of an architect to deliver a sustainable project, then what they might design and what they might deliver might not end up being the real building that's put up. Now, I'm not going to go into too much detail in the slide. Again, this is just to explain that sustainable construction projects have a little bit of additional complexity compared to a normal construction project. The primary reason, and what's worth mentioning here, is that there's usually a target set from building owners, so high-level targets, and those targets need to be translated into an actual design and then eventually a procurement sheet. Now, in this process, there's a lot of back and forth that's happening with sustainability consultants, and this is what we want to tackle at 2050 Materials and start solving problems around. Now, a little bit on what we actually do now. So what 2050 Materials tries to enable is we are building a workflow to track, implement, and then build the low carbon buildings that need to be built within the budget of a client as well as on time. So to do that, we're building a workflow that allows you to preset whatever climate targets and constraints you have for your project. And then what our platform does is that you can receive optimized designs from a materiality perspective that allow you to meet those targets. And then, very relevant to this specific topic of the webinar today, we have a large product database where you can both find products as well as source them and eventually put them together to report on the performance of the building. Now, the reason we focus so much on materials as a group, as a company, as friends who are working on this idea, is that what we kept hearing from architects and designers is that the consideration of all of the new and alternative materials is very necessary, and it's something that clients are asking for as well, and also architects want to look at. However, the fact that there's all of these new materials and all of these new parameters that need to be looked at adds a layer of complexity to the specification process. Now, while it's a lovely idea to think that everyone will learn every single detail on these materials and really be an expert on what they need to specify in order to align their design with sustainable development, we think that that simplification is warranted in this case. So what we try to do is essentially put the data around these materials in front and then allow easy comparison. Now, today we have an MVP which we developed in a lean approach with continuous industry leaders. On our platform, which I'll quickly show as well, you can discover sustainable projects. Sustainable products. You can understand their sustainability performance, and you can contact manufacturers directly on the site. Besides that, we've also developed some tools that allow you to optimize the impacts of your building at an early stage and engage with your client during the target setting exercise, as well as during the initial discussions of a project before a design has been made. Now, what we're currently developing, and I'll talk a little bit about that also in the Q&A if there's interest, is what we call a project workflow, which is essentially the bridging of the tool side of things with the product library. A little bit of feedback, I guess, from the industry. So when we launched our beta publicly, we've received quite nice feedback from the industry. Of course, it's very nice as a group to just get some positive feedback after working so hard on this topic. What's even more important than that for us is that really there seems to be something we have gotten right, and that is that in the space of sustainability and materials, there really seems to be a gap in a solution that helps architects and designers really understand the data behind those products. Now, I would like to show some screens on how it works and then run through a quick demo as well. And then I'm very happy to take any sort of questions or elaborate more on what we actually provide as a company. So the first feature that I would like to talk about is the product product research. So we have a library, as I mentioned, where products are listed specifically by manufacturers. So these are not generic materials, but they're actual products which are linked to suppliers. And these suppliers give us all of the certifications that they have. So they might provide environmental product declarations, cradle-to-cradle certifications, anything else that might indicate the performance of the product. What we do as a company, and I'll show that in the demo, is we digitize a lot of that information and we simplify it for the specific stakeholder, which is designers and architects. Now, besides the product research side, we make it easy to compare products. So you can select specific products and create these kind of comparison reports, which again, I'll show. What's very important about these comparison reports is they are useful, we think, both in the specification process as well as in value engineering exercises. So going back to my point previously that the design process and the procurement are currently decoupled, these reports help us to give tools to architects that can walk into a value engineering exercise and still fight for the sustainable product. Now, finally, we have developed an embodied carbon tool, which is a dynamic tool to communicate the impact of a specific design, as well as to start conversations with clients around what materials should be used if we want to achieve specific sustainability targets. Now, besides all of that, we are doing a lot of work to connect the dots in the sustainable construction processes, and that includes writing a lot of content on our sites, on our Medium page, as well as generating all kinds of tools, sometimes custom for specific clients and sometimes public for all users of our site, to help them do all kinds of things. So just to give an example, in June, we launched a campaign where we essentially provided sustainable buildups of walls using real products that are out there on the market, with some data on their embodied carbon, as well as recyclability and circularity. We are also helping some manufacturers bring to the front the sustainability performance of their products, and we create what they call digital product passports. Recently, we developed the first version of a circularity indicator. So this is an indicator that collects all kinds of information from environmental product declarations and puts them into a simple metric that allows you to objectively compare products. And currently, we're also working on some target setting tools for real estate owners and real estate companies. Now, I invite everyone to go out and check what we've built. It's app.2050-materials.com. And meanwhile, I can also switch to another tab and show a quick demo of our platform. Let me see how I can do that quickly. Okay. I think you can now see, or now you can see my screen. So as I mentioned, what we have out there is not a finalized product. It's what we call our beta. So it's an initial MVP of what we are trying to get to. There's two sides of this product that I would like to show. The first side has to do with tools that we provide to the users, and the second side has to do with the product library. So on the tool side of things, we've developed an embodied carbon dynamic tool, what we call a design optimization tool, where you're able to select a type of building you're working on. We currently have 4 types of buildings: residential, commercial, high-rise, and low-rise. And then you can generate one of our dynamic tools. What you see when you generate a dynamic tool is some data on the embodied carbon of the building. We currently cover life cycle stages A1 to A3, so essentially everything related to the manufacturing of these sustainable of these materials. And we also translate these kind of metrics into a warming potential metric, which is essentially an indication of the contribution of this kind of building to a specific climate scenario. Now, the reason I've called this tool dynamic is that you can go into all of these dropdowns and play around with different selections. And when you do that, we automatically calculate the embodied carbon footprint of the building per meter squared. as well as all of the other metrics that relate to that. So the water footprint, the warming potential, as well as how this kind of building compares to an average building. Now, all of these are applicable both on the structural components, so substructure, frame, floors, walls, as well as all the way down to essentially finishes, both wall and floor finishes, and all of those. Now, what is interesting about these tools, I think, and what we hear, especially from architects we work with, is that you can use them to get an initial understanding of the hotspots and the primary sources of emissions in a specific selection of materials. So what you see here is a plot of the embodied carbon footprint per meter squared of gross internal area of the building for each of the selections. So what you can see is that if I select precast concrete in my frame, you would see this appear here. And if you hover over it, you would see the amount of emissions that are related to that. And then we have this black line that indicates what we consider to be the baseline. So essentially what is most commonly used in that component of the building. So you can see whether you are on average exceeding that baseline or below it. Then one last thing I will show is all of this information can be made specific for your project. So you can enter the occupancy level of the building, the floor area, the lifetime that is expected for the building, as well as an estimated value. And what we provide here is the total carbon footprint of the building, so not per meter squared, but the entire amount, as well as the same number normalized in a few different units. So for example, we show the carbon footprint per meter squared per year. So that is something that indicates for the lifetime of the building how much emissions are attributed. And we do the same on a per person basis. Now, the reason I said earlier that we have these kind of tools to generate discussion in the construction sector is that we want architects and we want designers to go up to their clients and discuss the differences between building a building for 120 people last an expected lifetime of 100 years versus building a building that, for example, will be a pop-up store that only lasts, say, 1 year or 5 years and will only have an occupancy level that is much, much lower. So we want to generate discussion around, how much carbon footprint is each type of building, depending on its use case, supposed to emit. And we are providing these kind of metrics, I would say, before there is official benchmarks from regulators. Now, all of this information is exportable. And again, I invite you to check out these tools. Everything is free currently on our website, so you can export these reports or go into your client meetings and generate some of this discussion. And then if I quickly move to the product side of things, so as I said, here we have the product library. You can search for products in a few different ways. You can search, for example, by application, so by building applications in the building. You can also type for a specific product. So I can search, for example, for tiles. And I will see here all of the tiles that were listed by manufacturers on our website. Now, what we try to do is we create all kinds of filters to enable architects to get really to the specifications of a product that really solve some of their needs. And that includes filtering the type of material. So you can, for example, just select clay as a material. And you can also filter according to different things. So the product type, the company that is providing it, or the brand, as well as the fire performance, the product certification. So if you're looking, for example, just for products that have environmental product declarations, you can just filter for that. Now, within this process, you can open a product page. You see all of the relevant information that has been provided by manufacturers. You see certifications here that are downloadable as PDFs. And then a lot of the work that we do as a company is that we extract information from these certifications and we digitize it in a format that is easy to find and to compare between products. Now, of course, you might have additional questions, and that's why we create a direct link with the manufacturers. So you can already directly go to the manufacturers and ask an additional question, order samples, do anything else that you, or request anything else that you might need. Now, one last thing I want to show is the comparison aspect. So you can select a few products and add them to your comparison cart that you see above. I'm just going to add a few products here. Now, when you click the comparison page, you get some of these reports earlier, where you see the types of products with the images and the manufacturers, as well as all of the sustainability information linked to those products and some technical specifications. So all of this, again, is something that you can export and go into a client meeting or anywhere that you would find this useful. Now, one very last thing I want to talk about, and I have to go to a manufacturer that has filled in this information. Something we do as a company is that when we talk about sustainable materials, often the focus is on carbon. We, of course, understand the need to specify low carbon materials, and this is very relevant, of course, in the discussions around minimizing the impacts of climate change. However, we acknowledge that carbon is not the full picture, especially when we look at building materials. It's extremely important to consider aspects like the circularity of materials, so both how much secondary material goes into each product, as well as what you can do at the end of life of the product. It's important to consider the health aspects of each product. It's important to consider how the company that manufactures it is actually running their business and creating processes around it. So because all of this data is a little bit difficult to capture on its own, what we've created is what we call a transparency questionnaire. Excuse me. So the transparency questionnaire is a list of questions that manufacturers have the option to answer. And they cover all kinds of data. So we ask questions like, what is the material's origin and the location of the manufacturing plant, as well as more specific questions on the lifespan of materials, the deconstruction and reuse, as well as the disposal and the end of life of those materials. So this covers a lot of the circularity metrics. We also go into health aspects. So if the product contains any red list materials or any restricted substances from the REACH list, as well as finally more on the governance of the company. So indicating whether the company has a modern day slavery policy, for example, or whether they have an ethical trade policy. Now, of course, this is not an exhaustive list, and it's something that we're continuously working on, but I wanted to show it, especially in case someone is particularly interested. I'm happy to discuss it in the Q&A, because again, we as a company want to classify sustainability as really a holistic, from a holistic perspective, and not just be laser focused on the carbon numbers. I think there's a few different functionalities. I really invite people again to go check out our website. It's app.2050-materials.com. And of course, any questions you might have now, I'm very happy to answer. And I will stop sharing now.
Okay. Thank you, Phanos, for sharing your amazing work with us. We will have a Q&A session after the next presentation. So now we are moving to our second group of speakers, Rachael, Mutheu, and Githaiga from the Kenya Green Building Society. Welcome, Rachael and Roy.
Thank you so much, Danielle. Hello, everyone. My name is Rachael Mutheu from Kenya Green Building Society, and we have my colleague here, Githaiga. So we'll just do a quick introduction and get started on the presentation. Thank you so much, Phanos, for the great work you're doing at sorry, my computer is misbehaving for a moment there. I'm just trying to share my screen. Maybe Ray, you could introduce yourself as I share the screen.
Yeah. So thank you very much, Rachael, for that intro. My name is Githaiga. am a board member at the Kenya Green Building Society, and we'll just be jumping into talking about the materials and the modules that we've been working on at Kenya Green Building Society. As Rachael is sharing the screen, there are two programs that we at Kenya Green Building Society actually worked on. One of them was the affordable ABMT workstream, which was ideally supposed to, or at least was looking towards solving or trying to solve affordable housing. Whereas the second one was the Jenga Green application and the module for sustainable materials put together. The next slides, Rachael, if you don't mind.
Yeah, so let me just pick it up from here. Thanks, Roy. Um, Roy has introduced himself. My name is Rachael Mutheu. I'll just do a quick bio of what I do at Kenya Green Building Society and get into what we do at Kenya Green Building Society and just get started on the two work streams you've mentioned, Roy. The KGBS, which is short for Kenya Green Building Society, is a non-profit member-based organization that was established to lead the transformation of Kenya's built environment to promote healthy and efficiency within the industry. So we are a member of the World GBC, which has become the strongest local, regional, and global action network for the built environment, and we do a lot of work through programs and interventions, but we have a mission to advocate, educate, and certify green buildings in order to achieve environmentally, socially, and economically progressive an economically progressive industry. So we do a lot of programs, but again, we will only touch on the widely fit within the output of tools and products that assist in sustainable development of the built environment, which are used in the construction value chain. And this will be the Jenga Green Library and the ABMT workstream. So I'll let you, Roy, do a quick introduction of the Jenga and a brief history of where it went, and then I will proceed in the objectives of what the Green Library. Oh, all right. So I think your network is a bit misbehaving as well. I don't know what's happening on this side. But I'll take on with the introduction. So the Jenga Green Library is a directory of green building materials. So it's not because we've already had Phanos go ahead of us with materials 2050. So what Jenga Green Library is doing is also within that objective of trying to provide a one-stop shop to enable anyone within the built environment who wants to make use of low carbon materials or make use of sustainable materials in their project to sort of have a platform that they can make use of. So it is a program that we've been working on and just recently launched from beta to actual production apps. We have a web app and mobile apps. So it was done in partnership with FSD Kenya, that is the financial sector depending Kenya. And so the design of the library is to enable the promotion of climate action and sustainability within the movement. I don't know, Ray, are you able to say something so that I know that we are still together?
Yes, I believe I'm back. Sorry about that.
Awesome,
I had a
awesome.
weird connection. So I'll just jump
Go
into
ahead.
briefly too, because I think it's very important for us to understand where the Jenga Green Library actually was begotten from. So initially, what we did at KGBS was realize that we needed more like a specifications document or a specifications docket where we're actually looking at materials and sustainable materials for that matter. And with some of our members having collaborated and discussed this with other GBCs around the world, we managed to capture Malaysia GBC and NatSpec, which is the National Building Specifications in Australia. And they guided us and gave us, I guess, even the go ahead to even use some of the information or just a roadmap into how to develop our own. But what we did beyond that was also developing our own application. And so this program was ideally even introduced into the market in 2020 during the World Green Building Week. That was September 2020. Yeah, so that's just a history of where the library actually came from. So I'll let you, Rachel, carry on the next slides on the objectives.
Thank you so much, Roy. So objectives of the are one, to provide a single source of reviewed green building materials and services into the market to ease the uptake on this sustainable building materials. And the reason for this is because just being interactive and just going um, to the ground and having a conversation with the players of the built industry, be it it's a single family homeowner or the developers, you find that they don't you ask the question of, are you in the market, or are you trying to build with, within the guidance of sustainability, or are you trying to get sustainable materials? And they will tell you that they definitely would like to do that, but the problem with being able to do that is the lack of availability of the materials to go ahead and do that. So this is a big gap within the supply, not really within the supply chain, but a big gap within the awareness of what materials are in the market for ease of this build of for ease of this uptake of the green building materials. So that was a big gap that we were trying to solve. Then the second, demystify now this green building products by democratizing the information on the product. So when we give you the product, or when we showcase the products on the platform, you're able to take them as the single source in objective one, but we also give you more information on, so we are saying this is a sustainable product. Why is it a sustainable product? So we list the efficiency feature of that particular product. And the other objective for the developers to train material suppliers, stroke manufacturers, and service providers. So this again, the linkage, as we said, you ask people, do you know if these things are manufactured in Kenya, or do you know of this particular product? And they'll be like, I have no idea. So I'm just using the conventional materials because I don't know any better. So then that another pickup that we were trying to answer, obtaining the tax components of the cost information. So we will do a preview of what the library looks like, and we'll see that it has pricing components for the materials with a disclaimer, of course, that these are prices as of this time period, so that if when we get to the point of advocating for tax incentives on materials, then we know where we are coming from, what are the costs right now, and where we see or envision the future looking like. Because as you remember, one of our other mandates as KGBS is advocacy. And then to number 4 is understanding the pricing of green materials. So the functionality of the library is that one, it is hosted on our website, the Jenga Green Library. We'll just do a quick dive through that. It's also available as a free Android and iPhone application for anyone to make use of. And I will be sharing the link to the library with everyone in the chat box after the presentation. But yeah, so you can access the library through this link tree link, and we have over 140 products and over 20 service providers. And since the launch, we've had 500 500 interactions within the web app, the mobile apps, the iPhone and the Android applications. So we definitely see the gaps we're trying to solve, getting people's attention with the interactions, and we definitely hope to grow the interactions more. We have a review metrics for the two. It is an open source assessment methodology ideally, because we want the work to be transparent, and we also give a disclaimer that since another challenge within the Kenyan market is the lack of a lot of data in terms of data sheets and all that, this is what we confidently have to say that we looked at when we were looking at all the products that are listed. So these are um, eight, um, eight metrics for review. So we looked at, is it a sustainably sourced product? So is it bamboo? Is it sustainably sourced wood product and all that? So just run through, or we'll just share the slides. I'll show you where on the website you're able to interact with the methodology for review, comments. This is again open source, so we are reviewing the library. Move on, so the comments are welcome. But we have the categories of products as steel. We have bathrooms and plumbing. We have, again, I will share. We will be sharing the documents and the details to the website so that you interact much more in detail with the library. But just to quickly take you through it, we also have service providers within the library. So this is divided into, so we have energy solutions and green building designs to consult. And sorry, we went to the, and we have another category on the circularity, which again is into the circular building products and recycling companies. So just a quick overview of what the library. I'll just share a quick snippet of a video. So I'll just post the video right there. That one shows you aspect, shows how you interact with the web app ideally. So once you're on the web app, we'll do a quick dive into it. You're able to find the different categories, then look at each product as you'd like. So here we are in Kwangu Kwako studio apartment. This is in modular construction. Then you're able to see the company name, the price per unit, and as we said, the price disclaimer to anyone who's posting the product within the directory and the company website, because the library is not essentially a sales website but rather just a platform of providing this information. So ideally we provide the link to the company website, then you're able to go interact with them further, and if you want to make a purchase then you do it directly on their site. But of importance is this part of description where we talk about what efficiency feature made this particular product get listed on the directory, which ideally for Pankwako studio apartments, which are made of prefabricated concrete. We look at the baseline construction in Kenya, which is common brick that is the fired brick and machine cut stone. So we look at the embodied energy in their manufacture, and with that comparison, then you see this apartments within the Kenyan industry, you have some sort of efficiency that you've achieved within the efficiency in embodied energy in materials. And again, the disclaimer we make is the data in the market for the whole life carbon is quite difficult to attain within the market, but we have to start somewhere, because if we're comparing it with the works on an international basis, then ideally we'd see the baseline becoming a bit higher. But for the case of our market, then we look at the baseline of really in well really materials that are highly energy intensive in their manufacture, and you just compare that. Then when you want to now go in depth with the material data sheets, you're able to do a download sort of application or function where you have to sign in to download any further details that you'd like. So I think so this now is on your mobile phone. So now you use it on application, which ideally, again, you see the same interface. You see an interface like the one you have on your screen, and you browse in the different categories. If you want to look at services, then you're able to go to services, see the credentials of the service providers. If you want to look at resource circularity, you look at either products or companies that are in the circularity space, and you go ahead with that. So I'll just move on to the next slide and just let everyone that will be sharing the link to access all this information to the library, both the web app and the mobile applications for your further interaction. So I'll introduce Ray to just introduce briefly the next work stream that we are working on in terms of sustainable building materials. And I look forward to the question session at the end of our presentation.
Thank you much. Thank you very much, Rachel, for that. So I'll just jump into the ABMTs. And before we do that, I will also speak about why we wrote alternative, appropriate, and emerging. Now, with this stream, we have alternative building materials and technologies. That's what it stands for. However, when we started this research, we came to realize that there's a reason why a lot of these things are just done and they're left as documents, because there's no appropriateness to it. So we started looking at appropriate building materials, which is more or less localized materials, which now leads also to localized services and the likes. Because one of the major things we're looking at solving or trying to solve is affordable housing. Blanket statement: as a shelter remains to be one of the most basic human needs, housing in this modern age is increasingly becoming scarce, and more so, affordable housing. The built environment in Kenya has in recent decades gone through many transformations, both physically and socially. As the population continues to grow, emphasis on affordable housing should be made a priority. So one thing you'll realize is that when we start talking about affordable and appropriate, alternative, and emerging building materials and technologies, we're trying to get towards a position where we are actually talking about affordable housing to the core of what it really is. Next slide, please. So that's what I was defining. So the appropriate building materials refers to the process, the materials and elements and tools that are comparable with local socio-cultural, economic, as well as physical, ecological environment of an area. And affordable housing is housing that is adequate and costs not more than 30% of the household's income per month. That is to rent or acquire. In the contents of that report that we delivered, the various building materials, both conventional and ABMTs, are analyzed based on their level of affordability. So one of the things that we had to do was look at different materials, different technologies, and also put them against one another and see what actually works, what is appropriate, what becomes a lot more affordable in terms of the term per se, but then also what is more on an emerging scope with regards to the availability of the materials, the location of where those materials are actually going to be used, cultural context, location. There was a lot that had to go through with that. But one of the major things that we started looking at, if you can go to the next slide, Rachel, based on the objectives, was to analyze those past reports and research findings undertaken by various professionals and institutions on appropriate building materials in Kenya. So this study ideally started out as alternative, but then we ended up going in the route of appropriate building materials. This putting, as Rachel had said, there's conventional materials that are generally used in the market. But what we did was put that against what we call as appropriate building materials. So you'll find that in different provinces or different counties in Kenya, you have materials that are more prevalent to that specific area as opposed to others. So that is what we tried, or at least that is what the basis of the program is all about. Also, one of the things was developing a zonal map on which these ABMTs will provide local communities with affordable housing solutions. So that was also part of it. So trying to see whether we can map these materials based on the localities where they come from. Next slide. So what you'll see there, if I can just describe this a little bit, that's a map of one of the counties, or at least the bridge between two counties. That's Kwale County, which is slightly towards the south, and Mombasa County, which is slightly towards the north. What that starts to show us is the availability of specific materials for that specific area. When you start to look at the other different locations, you start to find that there are materials that are locally available for that specific location. So that means that if you're trying to afford, or if you're trying to solve, or kind of get into the discussion of affordable housing, we have to start looking at localized materials, where they come from, how they're mined, is it sustainably processed or not. So that is also one of the things that we had to look at. And also, hello? Hello, I don't know what happened. Sorry about that. I don't know what happened to my link. However, what we start to see is that the inclusion of these materials from different counties in different locations in Kenya per se will now create that linkage between the location and the materials that are going to be used. Next slide, please. So if we're trying to improve the lives of people, we cannot overlook housing, especially as cities rapidly expand and the need for housing grows. Housing is at the root of many of other issues we work to address. The lack of quality shelter means that people live in areas with reduced access to clean water and sanitation, unreliable and unhealthy energy sources, increased exposure to disease, and low levels of financial security. About 20% of Kenyans live within the cities, and this urban population is growing at a 4.2% rate every year. With this level of growth, Nairobi, capital city of Kenya, requires at least 120,000 new housing units every year to meet that demand. Well, we only have our availability is only about 35,000 homes which are built, leaving the housing deficit growing by 85,000 units every year. So what you see there is a mismatched housing demand with regards to the growth of informal urban settlements, which is directly proportional. So you have what is currently available versus the demand that is there. Now, based on that, we have now these informal urban settlements keep growing. As and the demand for housing prices increased by 100% since 2004. This pushes lower income residents out of formal housing market and into these informal urban settlements or slums. So you can find that within Nairobi, the confines of Nairobi, we have 6 informal urban settlements, one of them being Kibera, which is the largest in Africa, if not the world. Next slide, please. And fortunately, the last. So what we came to realize is that we have to find a couple of creative strategies to try and solve this issue. We may be looking at materials, but then when you start looking at materials, you're also trying to solve affordable housing at the same time. So that's why one of the creative strategies is to look at alternative and appropriate building materials and technologies. Uh, we start to find that the land is too expensive. So if we can start to make this land more affordable, actually putting this into a perspective of someone who's living in that specific location, having creative financing, innovative design, keeping things simple but also creating good quality spaces, develop contracts with suppliers, which means you have close contracts with suppliers, so prices don't they're not hiked. Community supported labor, etc. So community supported labor, you're talking about culture, you're talking about it's a need based construction system per se. Instead of having to import people from different countries to actually come and build your houses. So there needs to be a shift of the idea from simply looking at cities as well, because one of the problems we are starting to see is that based on the previous slide that I had before, is that you have that deficit with regards to housing, but then the only focus there is about cities. So if we start to focus on secondary cities and towns, it would be an ideal situation to develop these strategies, therefore reducing the pressure on primary cities, which in turn reduces the pressure on informal urban settlements growth. So when the program for the alternative building materials work stream, the basic things that came out from this was we need to find creative ways of doing things, recognizing the cultural context, which is contextualizing the people's needs, understanding that housing isn't just a physical infrastructure, it is also a community infrastructure. So we had to go out of Nairobi to understand how people actually live, to understand how people build their houses. And then there's also zoning, which is an elaborate path towards affordable housing. Looking forward to your questions and comments further on from this. Thank you very much for listening to us. Uh, Back to you.
Thank you so much, Roy.
Thank
Um,
you.
so again, let me just do this. Put it in the chat, and yeah, back to you, Danielle.
Thank you very much, Rachel and Roy, for the interesting presentation. Now we are opening our questions and answer session. I would like to start with the question to Phanos. Uh, I would like to know if there are any regional limitations for using the 2050 materials too. I ask that because I come from Brazil and here is still a bit difficult to find manufacturers of sustainable materials.
Mm.
Unfortunately, most of the manufacturers come from North America or Europe. But if we start importing materials from these regions, in the end, it might not be so sustainable because of the long distance. So I would like to know if there are any tools for searching for manufacturers by region, so we could find these local manufacturers of sustainable materials.
Yeah, really good question, Danielle. Currently, we have products that are primarily covering European countries. I would say we do have some products in the US, some in Australia, in New Zealand. So there is no restriction per se for manufacturers listing their products on our platform. However, simply due to the users that we have started by listing manufacturers that at least manufacture or supply in European countries and some in North America. However, what we plan to do is we want to get every sustainable manufacturer on the platform listed. And as a user, you can already pre-filter the products that you get in your selection according to the manufacturing country. And that's exactly to address the issue that you said, which is we don't want to send, for example, sustainable bamboo products from China to the UK to just provide that if there's already existing solutions that are local. So our approach is definitely to promote regional sourcing as much as possible, and you can already filter through some of these products on our platform. And maybe one last addition to that point is, I think we often assume start from the point that we assume that regional is better, and sometimes there's even the argument that maybe regional but unsustainable materials are better than far away and sustainable ones. And I don't think that's a clear question to answer. What we are doing to solving that, and hopefully that will be live soon as well, is we will soon be able to show the carbon footprint of the product related to the manufacturing, and then compare that to the estimated transport emissions depending on where your project site is relative to the manufacturing site. So I think being able to provide those kind of tools is very much also what we want to offer to the industry.
Great. So here we have some questions on the chat. There's one question from Cecilia to all of the panelists. She's asking, what is the initial starting point you see for alternative materials discussions to happen? In other words, what attracts people to the discussion?
I think, to be fairly honest, one of the major things that we came to realize was cost. That's the main attraction to people, ideally on the ground. So if something is cheap, they're going to be more prone to using that material or that technology, whatever it is. And that is where we shifted the alternative, well, quote unquote, alternative to more appropriate materials, because appropriate is more localized, so that makes it slightly cheaper. But then also one thing that Phanos you mentioned that is also very important is you might find some localized materials that are not very sustainable versus other materials that are not locally available that are also sustainable. And we noticed that using burnt bricks is not sustainable because of the number of trees that are being cut down, as opposed to using sun-dried bricks, which might not be locally available in that specific location. So there's that balance needs to be. We need to find the balance, ideally, well, in an ideal situation, to make this topic or even this discussion more attractive to people on a cost and labor perspective.
Yeah, really good. Maybe just a short, I mean, I definitely agree with what was said. I think cost is obviously the main driving factor in all of these choices, especially in the construction sector, and that makes a lot of sense. Maybe what the additional context I can provide from some of the companies that we work with, often the demand starts from the client. So some clients that want to build new buildings are realizing that they can maximize the value of their building by including some sustainability aspects to it. That might be getting a certification for the building, for example, like a WELL certification or LEED certification. It can also be by maximizing the sustainability performance of the building by specifying more sustainable materials. Although I have to say that to a big extent, those kind of materials are also what the end user of the building would see. So it's often interiors, which is not a bad thing, but of course is not the maximum potential in terms of reducing emissions. But I guess from what we are seeing, client-driven demand is very strong. And then something that is, I think, quite prominent, at least in Europe. I'm not so aware about other regions of the world, but currently in Europe, a lot of architects have started realizing that their work contributes significantly to climate change, and they simply want to find ways to specify more sustainable materials. And that sometimes also means having the tools to convince their own clients to actually get those materials. So even if those materials might end up incurring additional costs, having the tools to actually be able to explain why it might make sense in the long run, either from a cost perspective or from simply a sustainability perspective, I think is something we are seeing strongly as well.
And I'd like to just add on to what my colleagues are saying in terms of so there's cost that is really really important in the discussions, and there's also the availability. And I just want to add on to the capacity building aspect. So sometimes you find, again, in the really rapidly growing market, some people are just growing or getting into development because the demand is there, without really knowing that they also play a huge role within the sustainability space. So capacity building all and every player of the industry definitely brings them to the table of now asking, okay, so now what are the next steps that I need to take from where I'm at now and to that level that we are talking about. Yeah.
And now we have another question from Dane. He's asking Phanos, what is your future dream goal for Materials 2050 in terms of user interaction with the website and the role of the website can play in the construction industry?
Okay, so maybe to answer that question, it's worth giving a little bit of background on my professional background. So before working on 2050 materials, I was working in the space of ESG and climate assessments for investors. And I was specifically working with a lot of real estate investors who try to set targets for climate neutrality within their portfolios by a certain year, often by 2050. So one of the key reasons I wanted to start working on 2050 materials is that what I saw in my previous job is that investors who often hold the money and take a big part of the decisions set specific targets of climate alignment that simply do not correlate with what happens on the ground. So they might say a very generic target like a net zero target for our portfolio for 2050, and it's not defined whether that net zero refers to embodied carbon or operational carbon. It's not defined whether within that net zero there's any health aspect considerations of the building. It's not defined, how do we, what exactly is the definition of net zero and how do we deliver on that target? So I'm giving a lot of this context to say that 2050 Materials is a software company, yes, but what we're trying to do is create a framework and a language around sustainability where ideally every single stakeholder that comes into play in order to build a building can go onto the platform and communicate with the same kind of words. So the ideal end goal of our platform is that a building owner, before they build a new building or before they start a new retrofit, can set specific targets that they can also report to their own investors, for example. And those targets are directly linked to real actions that architects, contractors, and manufacturers can follow, both to implement the completion of that project, but also to generate some sort of traceability and tracking of these KPIs that directly link to what is actually trying to be achieved. What I would like to avoid personally is that because there is so much subjectivity in the space of sustainability, my personal fear, if you like, is that everyone sets their own targets and everyone tries to achieve them in a very custom way, and then we don't really achieve anything from a global perspective. So if we can be the platform that really connects people and gives them a common framework to discuss and then eventually build these low carbon buildings, then that's great. And if we manage to do it before 2050, that's a lot greater.
Now, I don't think we have any more questions from the chat. So I'd like to thank all of the speakers, and we now are going to a 10 minutes break. And after that, we will continue with the presentations from Neo Turnan and Aida Zare. So see you back in 10 minutes.
Thank you.
Welcome back to the third session of the Digital Tools for Green Buildings Design webinar. We already had two great presentations on the topic of sustainable materials, and we will continue now with our next speaker, Neil Turner from the Ecological Building Systems.
Okay, well, thank you very much.
And Neil, you are mute.
Am I on mute?
No, now we hear you. Now you're
Good. So let me just, some people say it's good that they can't hear me, but if I just go to share my screen, it doesn't want to come up again at the moment. Okay, can you all see this?
Yes, we see it.
Okay, excellent. Okay, well, good afternoon, everybody. My name's Neil Turner. I work for a company called Ecological Building Systems in the UK. Today was supposed to be presented by my colleague Joe Fitzgerald, and he heads up the technical department in Ireland. So I'm standing in for him today. So basically, I'm going to be talking about natural insulation materials for construction. I'll just introduce both Joe and myself. Joe works in our Ireland office. He's the technical specification manager. And he's basically got a diploma in green engineering. He also does things such as thermal modeling calculations, WUFI calculations, and he's also a certified passive house tradesperson. In terms of myself, I'm quite unusual in that I'm a scientist by education, but I've worked in construction now for 25 years. You can tell that I've been around a fair while because of the grey hair. And my bulk of experience in construction is really with natural insulation. I used to manufacture cellulose insulation from recycled newspaper. I'm also involved in developing European standards for new insulation products and also developing new test methods. And as I say, the bulk of my experience in construction is in natural insulation. Okay, so in terms of ecological building systems, I'm going to very quickly run through some of the products that we supply. The main product line that we have is the ProClima range of air tightness and wind tightness membranes, tapes and seals. And it's very important that when you insulate buildings to a high standard, that you create an airtight and wind-tight line layer either side of the insulation. And this is so that you stop thermal bypass. So you get convection. If you have a leaky envelope, then air can just blow through your insulation and it doesn't work so well. So that's our main product line. And then what I'm going to be talking about today is the natural insulation products. So we do Gutex, which is wood fiber insulation. Diasin is a cork lime insulating plaster. So it contains a lot of cork, which in itself is a natural crop-based insulation. Thermo-Jute is a bat, a flexible bat that's friction fitted in between timbers. And it's made from hemp crops and a combination of hemp and also recycled jute bags. So the company that manufactures this is in Germany. And what they do is they import, in Switzerland, there's a Ritter chocolate group, which imports many tens of thousands of tons of cocoa from South America. And that cocoa is supplied in jute bags. Now, rather than throw those jute bags away and landfill them, they actually they mix it with hemp fiber and convert them into insulation. So not only are you preventing any carbon emission through the decomposition of these products in landfill, you're also locking a lot of embodied carbon in the building. The other product I'm going to mention today is just, this is not necessarily a natural insulation product. It's called Bosig. But this is a structural board. It's used for insulating door thresholds and window reveals. And it's actually made from recycled PUR, polyurethane. And polyurethane is a big problem in terms of end of life, because you can't, you have to have special licenses to landfill and dispose of the product. So we're actually taking this stream of waste polyurethane and converting it, upcycling it, if you like, into another product. So in terms of a company, our experience is obviously with building materials, but we don't just sell the products. We actually do a lot of education and training. So we run lots of CPD seminars explaining the benefits of these products. We also do a lot of design support with architects. So we do a lot of moisture calculations, thermal bridging calculations, and U-value thermal calculations. We also work closely with a number of bodies whose aim is to try and train contractors in how to actually build correctly. This is a major problem, not just in the UK and Ireland, but all over the world, a shortage of trained builders. So we get actively involved in that as well. Okay, so today I'm going to talk about the opportunities for low carbon natural insulation products, and then really talk about resource efficiency. What does it actually mean if you actually use more carbon materials with low carbon profiles in construction? What does it mean to the overall carbon footprint of construction? Then talk a bit about resource efficiency, and then I'm going to drill into some examples where these natural products are actually used in new build, but also in retrofit. What I will say is that in the UK, natural insulation products started their life in timber frame construction, in new build, but now they're being used extensively in retrofit. That there's certain properties that natural fiber insulation has, which lends itself very well to working in solid masonry buildings, whether it be solid brick or solid stone. Okay, so in terms of low carbon opportunities, this is a chart which basically shows the CO2 equivalents of different types of insulation products. So if you look at this dotted line in green, this would be a kind of carbon neutral product. In other words, the carbon that's already stored in the material would be equal to the carbon emitted in the sourcing, manufacturing, transport to site, use, and end of life. So what you see is that products, the petrochemical type products such as polystyrene, spray foams, PUR, PIR, mineral wool, these all have a positive kg CO2 equivalence. So it's usually expressed, it's actually expressed to how much thickness you need to get an R value of 20 at 234 meters squared. But if you look down the bottom, you see all of these natural products. So you've got denim bat, that's made from recycled jeans and clothes. You've got sheep's wool. You've then got cellulose that's made from recycled paper. You've got cork, you've got straw, and you've also got wood fiber. And what you find here is that these materials actually have a better than zero carbon profile. So the carbon that's stored in these products is greater than the carbon emissions during the whole life cycle from manufacture through to the end of life. Now, a lot of people are surprised by this, but natural insulation products are extensively used in traditional buildings, solid stone, solid brick, and they're also used in new build. So you can use these natural type insulation materials in a whole broad spectrum of building types. Okay, so in terms of resource efficiency, I know in Ireland they've already adopted the NZ standard, the nearly zero energy building standard for new builds. So people say, well, you know, what we're already now building to a much higher standard, why do we need to consider the materials? So, I mean, there is a standard which is actually more onerous than NZEB, and that's Passive House. But basically, there's really a sort of limit as to how thick you can necessarily insulate a wall or a roof or a floor. So you could then ask the question, well, how can you actually get more reduction in carbon impact of construction? So the theory is, the principle, what we've been promoting for the last 10, 15 years, is to say, well, you can push your building fabric as far as possible. And you must do that. You must adopt a fabric first approach. So you have thicker insulation, you cut your thermal bridging, choose careful material selection and planning, build quality, energy efficiency. You've got to have healthy buildings, so you've got to have ventilation when you're building to high insulation and air tightness. And you're having an overall low ecological impact and an ultra low energy demand in use. Now, the thing is that all of these things are essential if you're going to have lower carbon in construction. But the one thing that people tend to overlook is the actual carbon profile of materials. Now, at the moment, the building sector, as of, say, 2018, contributes about 39% of all global CO2 emissions. Now, 28% of those CO2 emissions are operational. So in other words, this is the lifetime CO2 emission from heating the building and cooking and cleaning and lighting and using electrical goods. But 11% of this 39 is actually the embodied energy in the construction materials. So, and what you'll find is, as we move along and our building standards get more and more better, lower U values, better requirements for the envelope and reduced air permeability, then all of a sudden the percentage of the embodied carbon of your materials becomes bigger and bigger and bigger. So why then choose natural insulation products? Well, a lot of these products contain very high levels of absorbed carbon, as I mentioned. And the best example I can give you is let's say, wood fiber. So wood fiber starts its life as a tree, which is throughout its life absorbing lots of CO2 and emitting oxygen. So when you convert the sort of waste offcuts from, let's say, a sawmill process, and you convert them into wood fiber, you're actually locking a lot of carbon into the building. So what one kilo of dry timber can sequester roughly 1.8 kilos of CO2 equivalents as carbon. And it's the same with other materials such as cellulose. So cellulose is made of paper. And then you've got hemp crops and you've got cork trees, which are all absorbing CO2 in their lifestyle. So when you use these materials in a building, that's making a much, much bigger contribution to reducing the overall CO2 impact of the building. Now, the critical aspect in terms of reducing carbon potential and considering materials, this graph is really showing that you have to do this at a very early stage. So in other words, when you're at the planning stage and the design stage, this is where you can start to have a much bigger impact in terms of reducing carbon than you can when you get to construction phase and operational and maintenance phase. So obviously in the UK at the moment and Ireland, there's a big drive to maybe build less new buildings and refurb existing buildings. There are lots of commentators who say the most potentially environmentally friendly building is the one that already exists. So obviously, if you build nothing, which is not possible, but in other words, you try and build less and maximize the use of existing assets. Then in terms of the choice of materials, this is where you talk about building clever. And then building efficiently is when you get to construction, and then operation and maintenance. So the critical thing here is that this early stage planning and design is where that you can have a really the biggest impact on reducing the carbon footprint of a building. Okay, so I'm now going to give you some examples of pictures of different materials. So what you see in the top left, this is the hemp jute flexible bat, and then the one on the top right is the wood fiber insulation board. Note that this one is now being fixed to the external of your timber frame structure. And I'm going to talk a bit about what this is actually doing. It's actually cutting the thermal bridges as well. Thermofleece is sheep's wool. And then this is just showing the sort of profile of wood fiber boards being linked together. So all of these natural products have very similar attributes. They're all breathable. They're all moisture vapor diffusion open. So they can absorb moisture vapor, but then release it when the climatic condition changes. So that helps you with the design of the building. You can design a building without using vapor barriers or other types of materials without causing any moisture problem. They all contain lots of carbon. They all give very good thermal performance in the winter. Their thermal values are very similar to mineral wool. And also these natural products, very high what's known as specific heat capacity. And the boards are also in particular very dense. And what that means is you can actually stop or reduce summer overheating. So if you could imagine all of the heat that's beating down on an envelope during the day, if you've got wood fiber externally, the wood fiber, because of its high heat capacity, can actually slow down the speed at which that heat transfers through the building envelope into the building. And then if you're in somewhere like the UK, by the time the heat does get through, you're then into night cooling, so that the heat is then moving from inside back outside anyway. So these are all the kind of performance benefits of the natural insulants. This is just a photograph of cellulose insulation. So this is a loose fill material made from recycled paper. And it has a very high recycled content. There is a small quantity of fire retardants that's added. Usually you're using bath salts, magnesium sulfate, and also things like boron compounds. And you can see here, this is where it's been open blown into a cold loft space. You can also have flexible bats that you can friction fit in between. This is the thermo hemp, and this is showing the sort of virtuous circle. So you've got your hemp crop, fiber treatment, you then process to make insulation, and then you then insulate in a home, and then you can recycle at the end of life as well. You know, some of these natural materials at the end of life, they can be used as a mulch. So you can use them to retain moisture in your rose beds in your garden. But it's now becoming more common that these materials, when a building is demolished at the end of life, then these materials are removed and reused. So you can see here that you've got a sort of closed loop in terms of a carbon cycle. And then this is just showing the sheep's wool. I know in the UK, the clothing industry for wool has diminished significantly. And there's a lot of spare capacity of wool, sheep wool in the UK. So there are a couple of companies now that actually convert the sheep's wool into insulation quilts. So this is just showing you here being insulated in between timbers. Now, I mentioned thermal bridges a few moments ago, and this is just the slide which is showing the importance of, you know, the different layers of insulation in the construction and the important role for each layer. So if I take you to the bottom here, you can see that your sort of primary insulation is being installed in between timber. And then you've got another layer of insulation which is laid across the top. So what you're doing is that you're cutting that thermal bridge through the timber. It's very important when you design that you minimize or eliminate thermal bridges. This is just showing an example of a sort of passive raft floor system. So here you've actually got a sort of petrochemical water resistant insulation below your floor slab. And you can see that this wraps around. And so you're then using wood fiber here externally to your timber, and this one has cellulose in between. And you've also got wood fiber internally as well. So you can see that this heat flow path here has got insulation, and you're actually blocking off this thermal bridge here, and you're also blocking off the thermal bridge there. Thermal bridges is a common problem. This is just a short video showing you an example where using wood fiber externally around a timber frame, you're kind of wrapping the building in a kind of tea cozy. So you're keeping your building warm like your pot of tea. So I'm just going to play this video. It's quite short.
On the outside of the timber frame wall, we will install Gutex multi-term. Between every stud, Gutex thermofiber will be blown to fill the stud, which is about 225 millimeters deep. In hard-to-reach areas where thermofiber can't be blown, I will be installing Gutex Thermoflex, which is a very flexible bat. And this can easily be fitted between studs. As you can see here, it self-supports. So in tricky areas, which we'll see later on, where the injection of thermofiber can't go, we'll be filling with these bats of Thermoflex at a later stage. On the outside of the walls, Gutex multi-term will be fitted, and the process will be to fit the multi-term back to the stud. After the multi-term is fitted, a membrane must be applied over it, because in this case, I have a block outer leaf. If we have a timber cladding outer leaf or a cement board, then a membrane is not required necessarily. But when you have a block or brick outer leaf, it is required to install a membrane called fronta humida. So this is the Solitex fronta humida membrane, which we'll see later on. And when the multi-term is fitted, this will be fitted in front of the Gutex multi-term and fixed back to the wall. The main screws for fastening the humida and Gutex to the wall are thermally broken Fisher screws called Thermofix 6H fixings. Following that, there will be wall ties fitted through the Gutex, the humida, and back to the stud to tie back to the outer leaf block work. Attaining high levels of air tightness and effective ventilation are key components of building a healthy passive house and a low energy passive house. Another aspect is thermal bridging, trying to minimize thermal bridges and the associated mold, condensation, and potential structural issues, as well as energy loss that can occur at these points. This is one of the main reasons I'm applying Gutex on the outside of the timber frame, because like all real buildings, it's inevitable that some thermal bridges can occur for structural steel connections and so on. On the foundation of our house here, we're using a core passive foundation system. So the whole foundation is a raft of insulation onto which the concrete is poured. So on the outside of this whole panel here, we have beneath this damp-proof membrane, the core insulation wraps right up. Yet this is thermally broken from below, but on the outside it could be a major thermal bridge. So this is where the Gutex has a key role to play in isolating thermal bridging. Because now the Gutex, because it's on the outside of the frame, 80 millimeters of Gutex is applied to the outside of this. And now this breaks the thermal bridge at the window, this steel at this point. So this is the key reason why Gutex is effective on the outside of the timber frame. It allows the breathability, insulates and maintains thermal continuity as well for the timber frame structure.
Okay, so that's just a video showing you this wraparound with a natural wood fiber insulation, cutting thermal bridging. and that's the link. So I seem to have. Oh, sorry about that. So yeah, this is just showing it as a graphical. You've got the cellulose insulation as your primary insulation in between your timbers, and then externally you've got your wood fiber, and you're basically protecting, you're stopping any thermal bridging through this steel member. So you can see that you've got uniform heat loss. Whereas if you replace the insulation with just a timber board, so there's no insulation here, you can see that you've got thermal bridging. This is just the same example with a roof. So basically you're wrapping the outside of your timber structure with wood fiber, natural wood fiber insulation. Okay, so in terms of on all wall, roof and ceilings, your service cavity plays an important role. So in other words, you've got battens, which creates a space on the internal face of your insulation. And that means you can run services without damaging the membranes or the insulation that you may use. But equally, if you want to boost your U value, then you can also improve the U value by insulating this zone as well with natural insulation. Okay, so I've got not so much time left, but I'm going to go through a couple of examples now. So this is just showing natural insulation in retrofits of old buildings. So you can see here you've got your roof, which has got the wood fiber on the outside. So that's an example of wood fiber. I mentioned about cork lime insulating plasters. This is a product called diathanite. Diathanite Evolution, diathanite Thermactive. And basically it's a mixture of cork, lime, diathemate powders, that they're from volcanic ash, perlite, cellulose, pumice. These are all blended together, and then you wet spray onto your brick or stone wall. All of these products, by the way, the wood fiber, the cellulose, and the diathanite, they've all got these environmental product declarations in accordance with the ISO 14025 and EN 15804. So all of the carbon claims are validated. But this is a cork lime product, and it's got similar properties as the fibrous material. So its thermal conductivity is about 0.037, similar to mineral wool and cellulose and wood. And also it's breathable, it's moisture vapor open. And the way it works is that you're basically either spraying or you're troweling by hand onto a solid masonry wall. And then once you've built up your layers to get the thermal value you need, then you have natural lime finishes and natural lime paint. And what happens is, because this material is breathable, then it means that moisture can move from inside to outside, but also moisture can move from outside to inside. So you never get a buildup of moisture in your brick or your insulation structure. This is just an example where the diathanite cork lime insulation was used. So this is it was 50 mil or so sprayed internally, and then you've got this really nice lime finish. So it's all properly insulated and moisture vapor open, but you've got lots of cork as well, which is improving the carbon profile of the product. This is a building in Cambridge, the University of Cambridge's Institute for Sustainable Leadership. And what they did here is that they applied the cork lime thermal plaster onto the internal face of the wall. And then what they did is they bonded wood fiber onto this and then did a lime finish. So this is giving you a sort of completely breathable from inside to outside and from outside to inside. Now this building actually achieved the ENERFIT, the Passive House Retrofit standard. And it also complied with the WELL standard. This is the sort of indoor air quality healthy living standard. So in other words, the volatile organics and the other pollutants from these insulation products are extremely low as well. This is the restoration of the Primark building in Belfast. This is actually using calcium silicate boards. So what they do here is that they apply a lime level coat, and then you're then bonding these calcium silicate boards onto the wall. Now these are breathable and moisture vapor diffusion open, and also very water capillary active. So they can absorb lots of moisture, but then release when the climatic condition changes. So this is just some more pictures just to show you the scale of the project. And this is another project. This is 18 Ormond Quay in Ireland. So you see this is before, and then this is after retrofitting. And again, they're using natural, breathable, low carbon insulation materials internally. The other thing to consider if you're going to use low carbon insulation materials is to use natural paints. You know, paints make a pretty big contribution to things like plastic usage and VOCs, indoor air quality, whereas you can actually now buy natural paints, which are kind of VOC free, volatile organic free, compostable, wipeable, and they don't contain any plastics. So yeah, according to the World Health Organization, there's a lot of toxic waste produced for every ton of paint that's manufactured. So the chemicals and plastic in the paint don't break down, ending up polluting your water streams. And there's a lot of microplastics that are entering into rivers and oceans from paint. So always consider using natural paints when paint finishing. So okay, that concludes my presentation. And as I say, I had to stand in for Joe at the very last minute, so I only got first sight of this yesterday. But I hope you enjoyed it. Thank you.
Thank you very much, Neil, for the interesting talk. Now we will continue with the presentation from Aida Zare from the Shiraz University of Arts. Just a quick reminder that after Aida's talk, we will have a second questions and answer session. So if you are watching us live from YouTube, feel free to send us questions to our speakers. So now I'm going to hand you over to Aida.
Thanks a lot. Let me share this. Excuse me. Okay, hello everyone. I'm Aida from Shiraz. I'm so glad being here. And today I'm gonna speak about earth material and its architecture in Iran. But before that, I'm going to speak about three main problems that we are struggling in this century. And I want to start from macro scale from our planet, and want to imagine about the place that we are living. Here you can see the galaxy Milky Way, and there are lots of dust in this galaxy, and you know that's one of this small dot is our planet Earth, and it contains a very nice and diverse, beautiful ecosystems from the rivers, mountains, and the deserts. And this integrated balanced ecosystem is very fragile, and it's face a very concerning problem, which is global warming. You know, I think that all of you know about this problem, and we are all experiencing a very hot summer here, and this goes hotter and hotter um, by every years. And I think about the causes of global warming, also the part of architecture and the emissions of carbon dioxide is speaked a lot. And I think in um, the first series of these webinars, it is completely clearly explained the amount of carbon emissions in a different part of the buildings, and also the building materials. So we can see that there is a global problem, and architecture have a part in this problem, and of course can have a part in solving this problem. And the other problem that I'm going to speak is occurred in this cities. The cities are the settlements that um, human beings made for living from 1,000 years ago. Here you can see Machu Picchu in Peru. And the cities that we were made for living were um, almost the cities that care about their context. They were more contextual, and they're more, of course, sustainable until around 2,000 years ago. Here we can see Yes City. The cities were more contextual, and they care about the their climatic context. But nowadays, they're struggling with a problem, which is urban heat island effect, and have some reasons like lack of vegetation in the cities, and different infrastructures. That it's something completely different with global warming. It's completely refers to the extra heat air temperature that's occurred in the cities, and the cities' air temperature is higher than their surroundings. And one of the main points of causing this effect, especially in arid climate and in capital cities, is using unappropriate material and dark material, and dark surfaces for urban surfaces, like pavements, and also the roofs and the other construction material. And last scale, and its problem is interior architecture. Is completely referred to the interior spaces that we are living, and they were supposed to be the spaces. Architecture is supposed to make some spaces that make the quality of life better, and appropriate for our activities, like living, studying, etc. And that's we're spending around 90% of our activities in the spaces that is designed and constructed by the architects. And nowadays we're hearing about a problem, which is sick building syndrome, that happen because of a lack of daylight, or thermal discomforts, or the other environmental factors that uh, do not work well in interior spaces. There are list of disease from inconstant disease, like feeling fatigue or having headache, to serious chronic disease like cancer, which are related to the spaces that we are living and working, depending on how much time we're spending in these spaces. This is really something considerable that's happening in interior spaces. And that's for these problems are some solutions, and the word sustainability is refers to the solutions, the different solutions in different scales, from sustainable development to indoor environmental quality, and indoor environmental quality is something that's have different factors like daylighting, thermal comfort, acoustic indoor air quality, and effective ventilation. Then to providing this um, kind of quality in our indoor spaces, and also to uh, mm, decreasing the other problems like urban heat island effect or global warming, we need to care more about sustainable designing. And there are different parts for sustainable designing and passive designing, different solutions, but there's something in uh, the all in this decision for designing, which is selecting the appropriate and sustainable material, and it's very important and effective in any scale. Uh, and nowadays we heard a lot about the sustainable material characteristics, like being non-toxic and being low embodied energy, or being recyclable. Uh, and today in this webinar, we see some examples of sustainable materials and natural materials. It was very interesting for me. And all natural material, geo-based material, or bio-based material that's gained from the earth, the nature, the earth, the fiber, or anything we can um, locally, they are locally available, are more low embodied, they have low embodied energy, and they are more recyclable, and they are more acceptable for using in the sustainable construction. But, today I'm focusing in earth material, and the, this material is something that has been noticed in recent years because of its deniable ecological benefits. And have a look and its life cycle assessment, we will find out that it's a very low embodied energy material, from extracting to construction, depending on which technique you wanna apply, and to demolishing the building. It can be very low embodied energy, and you do not need any manufacturing process or in factories. And also, um, if you if you use and find out the appropriate technique for applying the earth of your local from near your sites, and you do not need any transportation also, so it can be low embodied energy, and it's completely recyclable, and it has some environmental characteristics, like acting as a thermal mass, and also it can be effective depending on the depth of the walls, uh, or can be used in other elements of the building. It can be acoustic, and can absorb the toxin of the air, and it's not toxic, and it can toxifying the quality, so it can be effective in improving indoor air quality. But along that's environmental beneficial of earth materials. So one very interesting and important thing about this material is that it has a very unique originality, and the history of earth architecture is we can say uh, it's like the history of architecture itself. And we have lots of mm, uh, magnificent examples of earth architecture from different civilizations and uh, ancient civilizations. And it's very important to care about the cultural, economical, and also social aspects of this kind of material. And there are some programs, for example, World Heritage Art and Architecture program in UNESCO, and towards trying to conserve uh, this cultural heritage, I mean, earth architecture, and also knowing more about it and using more in contemporary architecture. In one of the program, we see the Terra Fibra Award, which is a global award in contemporary earth and fiber-based architecture that can show that these kind of natural materials have really something more than just ecological benefits. And as I told, there are nice examples around the world from this kind of architecture, but I'm going to show some examples from Iranian earth and architecture. And before that, it's better to know more about the geography and also the climatic conditions of this country. Iran has nearly a vast area, and it lays between two sea, Caspian Sea in the north of Iran, and Persian Gulf in south of Iran. Those two central uh, deserts here, and there's a mountain north of Iran and a mountain in west of Iran. So because of these geographical uh, conditions, it has climatic diverse from a moderate and rainy climate at north of Iran, and cold climates and west of Iran, arid and semi-arid climate, to hot and humid climate in south of Iran. Um, I just put some example of this diverse architecture of historical part of the city of I choose them from four different um, location. First one is from north of Iran, which has a rainy, moderate climate. It is Gorgan city. The other one is located in west of Iran, which has a cold climate, and the Oramanat. This one is Yazidi. I'm going to speak about the city more the rest of my presentation. It's located in the central part of Iran, and the last one is Bushehr, south of Iran, which has hot and humid climate. So just I wanna have a view toward the diversity of climate and also architecture of this country. Now. Uh, I'm going to speak about this matter, that when and where we did use the earth architecture. I started from this UNESCO World Site Heritage, which is Chogazambi Ziggurat. It's located in Susa. It was built around 4,000 years ago. It's a temple, a place of worship, which was built completely with mud brick, and in some of um, the in some places of this ziggurat is built by baked brick. The other example is Bam Citadel, which is located in Kerman in arid climate, and it was built in around 3,000 years ago, and before a very severe earthquake that happens in here. This citadel was, mm, I think, like the biggest adobe city and citadel in the world. But after that heavy earthquakes, some part of the citadel is ruined. The next example is Persepolis near Shiraz, and it's more famous because of its stone Persian columns. But it's interesting to know that the wall of this complex was made by adobes, and in this picture you can see the type and proportion of the adobes that were used to make the walls of the Persepolis. The next citadel is again located near Shiraz. It is the Izadha citadel, and it was built around 2,000 years ago. It was built by the beautiful light color earth of this region, which is very quality one. And we can see some of the buildings in this citadel rise around 5 story. And if you think about the time of constructing these buildings, you can notice that it can be something noticeable on its own time. Here in the right side, you can see a Sassanid arc uh, remains, and on the left side you can see the proportion of one of the adobes that were used for the first story of one of the buildings. This is 20 centimeters, a cubic adobes that were used for building this citadel. The next example is Maybot city in Yaz. It's again an ancient city that goes back to around 1,500 years ago. And it's completely made by Adobe, and it's a live city till now. It's working as an example of a sustainable Adobe city. Here you can see the gardens, also the houses of Maybot city, and the alleys, the castles. And one of the interesting point about the city that I'm going to speak about it is urban infrastructures, like this water storage, and it's you can see a dome shape uh, ceiling and four wind catchers around it. And the most part of this water storage is located underground. It's can storage the water in this desert, and this one is really a masterpiece, which is Maybot ice storage, ice house. We call it Yakhchal. And this ice storage um, is a very nice example of using architecture as a tool to improve the quality of life for the citizens. You can see here a pool in a very narrow depth that's give this chance to make ice in the winter. You know that deserts have a very cold winter, and they made ices in this pool, and they stored them in this structure, in this ice storage, and it works very well. And just by designing passive strategies, we can see that there is a very remarkable difference between the air temperature of indoor of this ice storage and outdoor of this ice storage, by using strategies like air sheltering, dome shape, the ceiling, and a massive adobe walls provide these thermal conditions. And here we can see a bowl that they stored the ice in it. And you know, all this building was made by Adobe, and It was plastered by a kind of lime Persian plaster, which called sarouj, which is water resistant. And here you can see the dome of Adobe dome of this ice storage. The other nice example of urban infrastructure in Maywood is its pigeon houses. But this picture is not Maywood pigeon houses. It's Zare pigeon house, which um, we had a research plan and about it, and I have better photos, so I selected this one. But it's similar to Maywood pigeon houses, and these pigeon houses was played a considerable role for providing pigeons waste that were used in agricultural land. And their way of making these pigeon houses, their structures, the module of the Adobe, and also caring about the condition of living the pigeons is really um, mm, it's really notable. And you can you can see that they made a place to accommodating the pigeons, and they use their pigeons waste. They use the pigeons waste for agriculturing, and I think it's a very nice example of the power of architecture to providing a better life condition, not even for human beings, but also for other creatures. And it's not about just architecture for humanity. It's about architecture for all creatures, and I think it's really nice and very beautiful, and it shows a very nice interaction of human beings, architecture, and its environment, and the other creatures. Another urban infrastructure is again is not in Maywood. It's in Nashtifan in South Khorasan. It's Nashtifan windmills, um, which were working as a windmill to convert the wind energy into mechanical energy. And they were made by Adobe, and also wood is used to some part of the uh, mill structure. The you know in one hand it's uh, the function of this building, and the other hand is the beauty and the cultural landscape that they're made in these regions. It's really eye-catching, and these windmills, Adobe windmills. In the next part, I'm going to speak about the villages, and I have some examples of vernacular architecture uh, from different regions that were made by almost by Adobe and Earth Architecture. This one belongs to Charmahal province with a cold climate, and you can see that these Adobe houses were made and organized in harmony with their uh, topography condition of these regions, which is located in the mountain. And this village is located in Sistan province with an arid climate, and you can see these passive adobe houses, and the strategy of making them making a passive cooling, but by using this material and by using an appropriate form and strategy. Uh, the other example is Naiband. Again, in no, it's in South. It's located in South Khorasan. You can see 2 or 3 stories houses made by Adobe in this village. The other one is Esfandiar. It's near to Neuban. Mm, but if you pay attention to these 2 villages, you can notice that although the climate and also the kind of earth that they use is near similar, but uh, the architecture typology is quite different. Um, There are 2 main points about this kind of architecture and earth material that I'm going to speak about it. The first one is diversity, especially in the when we look at the vernacular architecture of different regions, we can find out um, difference, and we can find unique and uh, contextual kind of architecture, which is not designed and constructed by architects, and they are constructed by local people. They do not know architecture, but they really did it very well, especially in the villages where um, mm, uh, when we may pay more attention to the different villages that are uh, that are the uh, features of vernacular architecture, we will find out that although they all use natural materials, and in sometimes even the locations are near, but according to the different matters that happens in their context, uh, we're seeing uh, a very nice diversity uh, in all this kind of architecture. And I think this gained from living and experiencing the nature by local people. I think they will they are well experienced according to um, their life conditions and their pattern of life. Uh, they really know how to work with these materials, and how to uh, make their habitat, their settlements in their own regions. The other important things is integrity. When we speak about earth architecture, um, we have uh, a lot of diversity. In the other hand, we have an integrity in any city by itself, or any villages. Uh, if we pay attention, we can see that the whole city and any part of the city have something in common. And I think one of the main points is about using um, the local material. For example, when you look at a Yas city, the historical part of this city, and it seems like uh, mm, covering all the surfaces with earth material, and it's better to say that. I want to feed back to the urban heat island effect problems, and have a compare with uh, our contemporary cities. You can see lots of difference in the context of this city with other part of again Yaz or the other cities around. So there is there's something in common, which is earth material of that regions I think it is very important to use the earth material of that regions, and also the techniques that is belong to that regions also. You saw the city in one glance, and here you can see the alleys and the landscape. It's Doulatabad Garden. It's wind catcher and outside inside it. Also, here are some examples of one of the houses that is located in courtyard houses of this city. When you go to the roof of these courtyard houses and have a look at the city context, you can see a very nice landscape. It's really beautiful and eye-catching. And the interior design and any details from the whole to the part, you can see uh, something similar, but also have its own function and have its own a different part. So this is very, very important. When we speak about earth architecture, we are speaking about diversity and also integrity. It's similar to the ecosystem itself. It's very diverse, but at the same time, it's integrated. Um, you can see that we do not have none of these matters in our contemporary cities. Of course, this one is really exaggerated because it's Tehran and the other capital cities of Iran is not that polluted, but it's very obvious that living in these cubic mm, let's say, inefficient and inefficient buildings. It's really energy consuming, and it's not good for the planet. It causes urban heat island effect, and also you can see the pollutions, and with this much of pollutions outdoor, you cannot have an indoor air quality or indoor environmental quality. So they are not responsive, they are not sustainable. But I think one of the most important is that they are not beautiful, and they are really ugly. And so this is the point, a very important point. Okay, now I'm afraid of losing the time. I'm going to speak about in the last part that where can we use earth architecture today. Uh, we saw some examples in the seminars today that they used very nice from a natural material and sustainable material. And for earth material, you can have a full earth construction. It's an example of a Métis handmade school by Anna Heringer. There are different techniques for using to constructing a full earth building, like rammed earth or adobe or clay concrete. There are different strategies depending on the mm, instrument and also the characteristic of the earth of any regions. You have to find an appropriate technique to make a constructing building. But in some countries like Iran, it's not that easy, and it's prohibited using earth material for constructing a full earth material. There's no standards to using this material for contemporary construction. But there's another sector that we can use earth material, which is interior design. It's easier and it's more possible, and it's very effective. you can apply earth material in interior architecture using them in earth floors or for plastering, and also using this material as a thermal mass. And depending at the depth of the earth material that you're using in interior spaces, it would be very effective in improving indoor environmental quality. There are some small examples of our interior design project that we had in Gele Studio in Shiraz. And here you can see an interior partitions that we made by pomegranate sticks, which was like a waste material in one of our friends' garden, and also straw and clay. And the other example again from Gele Studio, but for uh, interior designing of a doctor's office in Shiraz, and we want to have a greenhouse in this doctor's office because they were in the south part of this office. We had this chance to add an adobe um seats as a thermal mass and also a glazing, and made this semi-open space as working as a greenhouse. Here you can see the process of making the adobes that we designed for this adobe seats. So we try to uh, reduce the amount of mortar and reduce the masonry operations by designing these modules for this adobe. And another example of making a shader that we had to have a curtain out of the window of the sounds room of this doctor's office, and we wanted to have a handmade shader, and this was mostly like a research project for our studio, because we had to try different aggregates of um, sarouche, this ancient mortar, to make something water resistant. And we tested lots of aggregates, and we made 600 sarouche balls by 3 people in 2 weeks. And then we installed it in a wooden frame in this office. The last and the best that we can do by earth material is renovating, retrofitting, and refurbishment of existing buildings, existing earth sites. There are, having a full earth city or full earth building is not that easy, but if we start to renovating and retrofitting the mm, earth site, it would be very nice and pleasant. This project is belong to Emarat Horshid consultants in Tehran. They have a restoration program for Esfahak village, which is located in South Khorasan. And this village, after earthquake, were abandoned. And after some years, the villagers came back, wanted to came back to this city. And Emarat Horshid consultant have some programs cooperating with local peoples to renovating this village. And now around 7 guest house and the mosque, and also the Persian bathroom hammam of this village is renovated. And one of the very nice uh, kind of retrofitting or adaptive reuse is belong to designing a Esfahak Mod Research Center, and renovate the school of this village. as a mod research center, and there are some years that uh, professionals in earth architecture and also the local experts invite to this site, and some national and also international workshops happen in the site of Esfahik village in Esfahik Mat Research Center, and it's really a very nice thing that happens in this village. Here you can see the observatory that was made by SFAC students, SFAC Earth Research Center students, and they made this observatory by Adobe in the site of SFAC Research Center. Now I want to come back to the Milky Way galaxy. uh, in this picture, you can see the clean, starry night of Esfahak village, and that you can see the dust of a galaxy in this pleasant sky. And whenever I see this sky, and I think about this matter that in our cities we are deprived of seeing this sky every night. I think about this matter that if we have this chance to see it, maybe we act really better, and we could maybe we will have a better feeling toward being a part of this ecosystem. And I think it's very important to think about all our decisions and activities in any fields that we are active in, uh, to think about the other parts of this ecosystem and have an holistic idea toward this. Uh, Thanks everyone for your attentions, and I will hear.
Thank you very much, Ida, for the great presentation.
You're welcome.
I think on Ida's presentation, we had many great examples of how materials are used, are selected based not only on economical aspects, but also on cultural values. And we can see how this is also linked to sustainable architecture. And unfortunately, many of these values are lost when we see the contemporary examples you showed about the cities. And I think it's the maybe a task for the next generation to change a little bit of this and learn more with the vernacular architecture and this knowledge from the local communities. And then there is a question about the in your university, how this they teach this, and do the next generation is the next generation engaged in this, like changing a little bit how the contemporary architecture is done in your region, or we still follow the global examples of architecture that is not very sustainable and not very integrated into the local landscape and local climate?
This was my question.
Yes, it's for you.
Okay. I'm a teacher at Shiraz University of Arts, and I have some courses in. I add some art courses in the syllabus of the students of for bachelor students of architecture, and there are the student of interior architecture. Really. And I should say that know how to build these buildings is a very big problem. As a professor at university, having PhD in architecture, I really do not know how to make these kind of buildings, and there are a lot of details from structural points to plastering, and I really just know some of them, not all of them, but we are trying to have interactions with some of local experts, and that's why we have some workshops in anywhere that we can use this kind of a structure, and we are practicing. And I myself am really interested in the pedagogy of earth architecture, and I'm really uh, like to work in it. But briefly, I can say that if we want to have um, learning more about this kind of architecture, or if we have it seriously in our academic spaces, uh, we we should have practical activities along with theoretical points. These two must be attached together. It's not just only about the statics and about the, let's say, simulating, for example, making the arcs or etc. These details, and it's also about touching the earth, experiencing the earth architecture, earth material, and we must have some, we must add some hands-on experiences to teach this kind of architecture. And it's better to, there is really a lack of knowledge in this field. And first, we should try to um, be more knowledgeable, and then try to learn it to others. And it's not easy, but it's possible.
Yes. So here we have a question from Cecilia to both panelists. She's asking, how should we start to influence local contractors and architects to think about materials in terms of carbon sequestration, also in terms of locally appropriate coping earth architecture?
Um, should I answer this, or Neil, you want to answer?
Do you want me to? I'll have a go. Should I have a go?
Okay.
Okay. I think we tried for many years, manufacturers of sort of natural insulation products. We struggled for many years to make any big breakthrough with these products. And the way we made the breakthrough actually wasn't to focus too much on the carbon sequestration, but you focus on the other performance benefits of these products. So in other words, you say it's breathable, they're high thermal mass, so you reduce summer overheating. The other thing is that they're easy to install, and you don't need to wear special gloves or masks to install these products, whereas with quite a few other, what you would say would be more traditional materials, you do. So, mineral wool can be itchy. If you're spraying foams, then, you get lots of off-gassing. And then the next hurdle that we overcame is that as we grew the market, the price of our materials fell. So you've got economy of scale of manufacture. So the prices become a lot closer to what you would say are traditional materials. So once you start by convincing the clients about the performance benefits, and then you start talking about the carbon. And then what then happens is that seals the deal, as it were. But I must say, you see lots of things now on the media, TV, internet about problems with plastic pollution, problems with CO2 emissions, rising temperatures. And over the last sort of 10 to 15 years, that's become much more of it's more in the forefront. And, you've now got a younger generation of architects and builders who are a lot more receptive. They're a lot more liking the idea of considering these kind of materials. What is very interesting, I'm really interested about your earth buildings.
Thank you.
And in the UK, we have buildings that are made from a material called cob, which is like
Yeah, I know.
yeah. And there's a lot of the cork lime thermal plaster that we sell works very well with cob, and that's become a growing market for us. There's not a massive number of buildings, but there's still a lot of old cob buildings. And the other one is thatch roof. You see these straw roofs in the UK on the old stone buildings, and it's the same old story. I think there's only maybe 20 or 30 companies that can actually remember how to install a straw roof. And you mentioned about how do we get more people educated in not just these products, but how to install them as well, how to build with them.
Yeah.
So in summary, focus on the performance as well as the carbon, and then you've
Exactly.
Yeah.
Yeah, and you have 20 factory that know how to do it. But here there isn't any factory that even finding one person in each city is not easy. And people's tendency is really toward modern material, and it's a very important problem. And but the point is that we must first of all preserve them. But preserving and also renovating buildings, you will find that lots of things from building process and earth building characteristics. It can be like it can have lots of educational point for the person that do this. And about the last part of the question of here I have a question that is said that whether we should copy the earth architecture. uh, no, exactly no. The very important and interesting part of earth architecture is that you can be very creative while working with this material, and you can have a real beautiful, responsive, sustainable kind of architecture which can be unique for itself. And it's not about copying the former architecture, but I think obviously, if we want to work with earth material, we should know the literature review of making earth material. It's not possible. I'm meeting a very long, 1,000 years of story, and then starting to make something. Let's say to make a masterpiece. I think for making any masterpiece, it's needed to see the others, and then you can find out your own way. It's very important.
Okay. And yeah, and Cecilia also mentioned about some insulation materials. She mentioned that cellulose is great even for tropical climates where we tend to use gypsum materials. So I would like Neil to comment.
Yeah, what's interesting, a lot of people consider, let's say, the US as maybe USA
a little bit
of
about
not being very environmentally focused, shall we say. But what you find is that cellulose insulation, wood fiber, is actually a big percentage of the sort of timber frame market. A lot of construction in America for houses, domestic, is timber frame. And cellulose is a big percentage, much bigger than it is in the UK or in even many other parts of Europe. And that includes tropical areas as well. I mentioned about the wood fiber having a high specific heat capacity and density, so it can absorb lots of heat and reduce summer overheating. And that's a particular benefit in tropical climates. You know, if you can, I'm not sure of what a typical build-up would be on a, you know, let's say a pitch roof or a flat roof in a variety of different tropical countries. But if you've got timber joists, timber beams, if you can insulate in between with a natural insulation product and above as well, then, you know, you can take advantage not just of when it gets cold at night in the winter, but also in the summer you can prevent overheating as well. So these natural materials are used in hot countries, whether it be Australia, southern US, in those kind of countries.
Mm-hmm.
I try to show on my presentation, you know, natural insulation, you can do it on new builds or you can do it on old buildings. Basically, natural insulation materials can be used anywhere as long as you're above ground level. You can't use wood or cellulose below a concrete floor slab because it you know, it can't be subjected to high levels of water.
Uh-huh. And these natural materials, they need to go into any process, or they need any additive to protect them from natural decomposition, or do they last a long time?
Yeah, all of the natural insulation materials, they're all CE marked, so they've all got European certification. So there's test methods that are developed which talk, you know, thermal conductivity, reaction to fire, resistance to mold growth, all of these kind of parameters. So what you find is that the low density products, so you've got cellulose and the low density wood fiber that's blown, they will contain some fire retardant. So they tend to use things like bath salts, magnesium sulfate. But 95% of your formulation, or 93%, is cellulose and the rest is additive. And with wood fiber boards, obviously, you need to have a small amount of binder so that you can bind all of the fibers together. And also, they're also coated with a very small amount of a hydrophobic agent. So when you're building a construction, let's say on the west coast of the UK where it rains a lot, it kind of gives some weather resistance before you put either your brick wall or your timber cladding on the outside of it. So, but what you find is that this is all reflected in the EPDs, the environmental product declarations. So it tells you what the percentage is of the base material, and then the small percentage of the additives as well.
Mm-hmm. That's very interesting.
Yeah.
You previously you mentioned that when you're talking to a customer, first you talk about the benefits of the natural insulation materials. And today we see that this natural insulation, they have a smaller percentage of the market comparing to the conventional insulation materials. Do you believe this happens because the consumers don't know all of the benefits that these materials have, for not only for the environment but also for the health of the people, as you presented?
Yeah, it's a combination of both. The biggest challenge is still cost. You know, glass fiber, mineral wool is still very cheap.
But if we compare this cost to the total cost of the building, it's not that much, right?
No, that is true. But there's what you find is that these industry associations for the big mineral wool and the petrochemical polyurethane, polyisocyanurate, they have very powerful lobbies, and you know, as soon as you start to gain as soon as you grow too quickly, then they do think they'll drop the price, or you know, it's this kind of thing. You know, price is still an issue, even though it is. You know, I went to see a major builder 10 years ago, and maybe they build 20,000 houses every year. And we offered a really good price for our cellulose product. And he said, well, actually, you're still 30 pence a meter squared more expensive than mineral wool. So he said, over a year, if I multiply 20,000 houses by 200,000 square meters by 30 pence, he said, I'm £65,000 down. And you know, it's still, you know, there's still that thing. But luckily, even the bigger companies in the UK are now having to, because of regulation, consider using higher carbon sequestration materials. They can't just buy on price, because they get money to build a certain number of cheap, affordable houses for people who are maybe less wealthy. So when they build, say, 200 houses, they have to build 20 houses for low cost, or a low selling price, but then they have to build them to a very high specification.
Mm-hmm.
So that you know, even the bigger companies who've always been, oh well, I only interested in cost, they're now having to start to consider using these kind of materials.
Yes.
But as I say, the natural fiber market has grown considerably, especially since lockdown.
Mm-hmm. And as it's grow, it gets also, the cost gets also lower, right? So
It does, yeah. You have, as I say, you just get this economy of scale,
mm-hmm.
and also the you know, the manufacturing capacity is being increased rapidly. So there's now 4 or 5 brand new wood fiber factories being built in Europe, and lots of new cellulose factories, and so you see all of a sudden, you know, at the moment we reckon that maybe we are 1.5–2% of the total market, but that it's kind of now beginning to grow exponentially. So we now actually maybe 3 or 4% of the market, and in 2 years' time we could be 8%, 10%.
Yes. So you believe in the future. We
Yeah,
all hope that in the future it will get
yeah.
bigger. So we have one question for Aida. A question for Aida from Cecilia. She's asking if Aida has any online and affordable school training programs for earth architecture techniques. Um,
Mhm.
she is asking for recommendations for this.
Mhm. I know some earth schools, the base habitat, uh, which is located in Linz University in Austria. But it's not online, as I know. But Crater in France, and Amaco, if you know them, they have some online courses. One of them was, I think, really um, nice for starting in earth architecture, as training the basic of earth architecture materials, but it's in French. It's mm, if you can follow it and know more about this from Amaco website, uh, and also MOOC, MOOC, which is a online platform for online courses. Uh, you can find in the part of l'architecture durable. That means sustainable architecture, and they're introducing some online courses. One of them was about Astra and Co, and one of them was about earth architecture, construction in contemporary buildings. This one was very nice. And I know an academy in New Zealand, uh, which is, I think it's let me find the address. Earth Building, that's Academy, I think. Earth Building Academy, and it has 17 um, 17 session programs. It was really perfect, and it has some theoretical points and also some practical in um, wanted the students to do some practical activities, and it was really nice. And if how I can, please send an email to me. I will find the exact website, and I will send them for you to to reach and gain these classes. For the other art programs, art workshop, for example, that we have in Iran, we have to program in Esfahan Mud Research Center, but they are not online, and some of the workshops are English, and the 1 year whole workshop is in Persian. So for the online courses, I think one of the best one in English is Earth Academy, Earth Building Academy in New Zealand, and in French is the courses that's made by Amaco team. Yes,
Okay. Thank you so much,
if I
Aida.
can the uh, appropriate answer. So, is there any question for me? Oh, you're
I
welcome.
think that there's not any more questions. So, with that, we conclude today's session. I would like to thank everyone watching us from the YouTube, and thank once again to all of the speakers for being here today and providing us with an insightful discussion. And so, thank you, Neil, and thank you, Aida, and thank
You're
you to all
welcome.
of the other speakers. And yeah, I would like to also to invite everyone to watch our next session of Digital Tools for Green Buildings Designs webinar about Whole Life Carbon Part 2. That is going to be on next Wednesday at 3 p.m. Kenyan time, where we also are going to have a great group of speakers. So thank you.